Section 5.8, applying special right triangles. These are the objectives. Justify and apply properties of a 45, 45, 90 triangle and also a 30, 60, 90 triangle. No vocabulary. Let's move on to the next slide. This is theorem 5.8.1 or 45, 45, 90 triangle theorem. I'm going to ask you to refer to this portion of the formula. You can read this. It's basically the same thing as what you see here. But I'm actually going to cross this out. And I want you to look at the following. In a 45, 45, 90 triangle, this is what we call the legs. And the two legs are congruent. And again, this is an isosceles triangle, and you know that. So this side is congruent to this side. This is what we call the hypotenuse. And this is a relationship that you have between the leg and a hypotenuse, which is right here. The hypotenuse is equal to radical 2 times whatever the leg is. And again, in a 45, 45, 90, the leg is equal to the other leg because we have an isosceles triangle. Next slide. So here's where you apply that formula you saw on the previous slide. It says find the value of x, give your answer in simplest radical form. So this is the formula that I'm going to be using. Hypotenuse is equal to radical 2 times leg. I'm going to substitute the information that is given to me in the problem. I'm given x, I'm given 8. X is the hypotenuse, the 8 is the leg. So I'm going to simplify this. And this is my answer. Here's number 2. So notice that you have a right triangle here. Now notice in this problem, they're not telling you that this is a 45, 45, 90 triangle, but you know that since these two legs are congruent, you know that these two angles must be congruent. Since this is already 90 degrees, these have to be 45 and 45. Okay, so let's apply the formula for a 45, 45, 90, and you know that a hypotenuse is equal to radical 2 times the leg. So you substitute. The hypotenuse is 5, the leg is x. You solve for x, divide both sides by radical 2, and this is what you get. At this point, you don't stop. What you must do is you need to rationalize the denominator. And this is something that you did in Algebra 1. So the way they rationalize the denominator, or you need to make the radical disappear from the denominator, is you multiply by 1, but this 1 is hidden as radical 2 over radical 2. And once you do that, this is going to get rid of the radical in the denominator, and you get the following. You get 5 radical 2 in the numerator, and then radical 2 times radical 2 is radical 4, but radical 4 is equal to 2, and the denominator does not have a radical. So this is the final answer for number 2. Here's number 3. It says find the value of x, and again they don't tell you this is a 45, 45, 90, but you are given that these two angles are congruent, and this is already 90, so you know that these are 45. Apply the formula, substitute. In this case, the hypotenuse is x, the leg is 10 radical 2. You substitute it into the formula. And at this point, you want to multiply radical 2 times radical 2, which is radical 4. But radical 4 is equal to 2, so that's why we end up with 2 times radical 10. So x is equal to 20. We're done with 3. Let's move on to 4. Excuse me. So again, 45, 45, 90. Use the formula. Hypotenuse is 16, leg is x. Divide both sides by radical 2. Again, you have to rationalize here. Multiply top and bottom by radical 2. And you end up with the following. At this point, don't stop because you notice that 16 and 2 can be simplified. Your final answer is 8 radical 2. Let's move on to the next slide. So what happens when you have a 30, 60, 90 triangle? This is the formula that you use. The 30, 60, 90 triangle theorem. And again, I want you to ignore this. Quick review. You know that this is the pen. You know this is the hypotenuse. This and this are short leg, long leg. And you know this just by looking at the opposite angle to them. So this is 30. This is going to have to be smaller than the opposite. I mean, this leg it has opposite angle to 60. So this is the formula you use for a 30, 60, 90 triangle. This is a relationship you have between the hypotenuse and the short leg. The hypotenuse is equal to 2 times the short leg. So here, this relationship. And you also have this other relationship between the long leg and the short leg. The long leg is equal to radical 3 times the short leg. Okay, so these are the two formulas that you're going to be using for a 30, 60, 90 triangle. And notice that both of them, they relate to the short leg. Hypotenuse to short leg, long leg to short leg. Okay, let's move on to the next slide. This is where we apply the formula. Just find the values of x and y in simplest radical form. So let me highlight the sides. Hypotenuse, long leg, short leg. You can see them in front of you. So then I'm going to find first x. Once I use this formula and I substitute, I notice that the hypotenuse is 22 and the short leg is x. I substitute the values into the formula. This is what I get. Solve for x. X is equal to 11. So now I still need to find y, which is the long leg. And again, there's a relationship between the short leg and the long leg. Here's the formula you saw on the previous slide. I substitute. Again, I found out that x is equal to 11. That's why you have 11 here. The long leg is y. Simplify this. Radical 3 times 11 is the same thing as 11 radical 3. We're done with 5. Let's move on to next slide. Again, same directions. 30, 60, 90 triangle. If this is 60, this has to be 30 degrees. Highlight the sides. Apply the formulas. So now I'm going to work with long leg and short leg because I had the relationship between the short leg and the hypotenuse. They're both variables, so I'm not going to get anywhere. But here I'm given the long leg, so I can find x. So once I substitute values that I'm given in the right triangle into the formula, I have this radical 10 times radical 3 equals radical 3 times x. Divide both sides by radical 3, and you get an x is equal to 10. So now I'm going to find the hypotenuse. This one's going to be easy. This is a relationship that I have between the hypotenuse and the short leg. I substitute 2 times 10 because the short leg is 10. So y is equal to 20. We are done with number 6. Let's go to number 7, or actually the next slide, which is 7. It says find the values of x and y. Simplest radical form, same directions. This looks a little bit different, but nothing you can handle. Notice that this is 150 degrees, so you know that this is going to have to be 30 degrees, and you know that this is 60 degrees. But let's move on. So you have a 30, 60, 90 triangle. This is the hypotenuse, short leg, long leg. So I'm going to find the short leg first. So I have the relationship with the hypotenuse and short leg. This is the formula you saw. I substitute. Hypotenuse is radical 6. Short leg is x. So I divide both sides by 2. And I get radical 6 over 2. At this point, we're done. You don't have to rationalize y because this is not a radical in the denominator. This is just 2. This is not radical 2, it's just 2. So we're done with x. Now I need to find y. This is the formula the relationship that I have between the long leg and the short leg. I substitute. At this point, all I need to do is multiply radical 3 times 6 over radical 3. Remember, this is over 1. So you end up with radical 18 over 2, but radical 18 can be simplified because you need to give the answer in simplest radical form. Radical 18 becomes 3 radical 2, and then just bring over the 2, and this is your answer to number 7. Let's move on to the next one. Here's number 8. Notice that you're given that you have pair lines. This is 30 degrees, and you should know that this is 30 degrees because of alternating triangles. If this is 30 degrees, or another way you can do this is perpendicular to the transversal, so you know that this has to be also perpendicular. If this is 30, this has to be 60. So that's how you end up with those degree measurements. Now you have a 30, 60, 90 triangle, so you apply the formulas. Again, this is your hypotenuse, X is your short leg, this is your long leg. You use this relationship between the long leg and the short leg, substitute the values. I know that the long leg is 10 radical 3, the short leg is X, solve for X is equal to 10. At this point, you find the hypotenuse. You use the relationship between the hypotenuse and the short leg. Substitute, y is equal to 20. Let's move on to the next slide. Find x and y. And again, this looks a little more complicated. They don't give you the degree measurements. But you know that this is 90. So you know that these two angles must equal 90. So you can work with this. N plus 2n equals 90, and using that you should see that this is going to be 30 degrees and this is going to have to be 60 degrees. Go through the algebra. So you have your long leg, short leg, hypotenuse. Use the formula. First find the short leg. You're given the hypotenuse. So then you substitute. You have 6 is equal to 2 times x. Divide both sides by 2. X is equal to 3. To find the long leg, use the other relationship. Substitute. You end up with y is equal to radical 3 times 3, which is the following. Y is equal to 3 radical 3. You're done with 9. This is the last problem, and this is going to be a little bit different. I'm not going to give you every single step, but you should be able to work through the problem and come up with the values that you're going to see in the video. So here we go. This is a square with a diagonal with length 20 centimeters, and you want to find the perimeter and the area of this figure. This is the picture that goes with it. This is a square. The diagonal is 20 centimeters. Since it's a square, you know this is 90 degrees, and this is equal to this, so this is 45, 45. From here, if you apply the formulas for 45, 45, 90, you should be able to see why we get 10 radical 2. And if you need assistance, I can help you in class or clarify this in class. And from here, you should be able to find the perimeter and the area, and I give you those two values, and this is what you should be getting. And again, I can clarify this portion too in class, if you would like me to. Last one, 11. An equilateral triangle with height 24 inches. So here's the picture that goes with number 11. This is an equilateral triangle. So now you know that these two angles are 60 degrees. So now you have a 30, 60, 90 triangle. You should be able to find this short leg given the long leg, which is 8 radical 3. Since I'm going to look for the perimeter and the area, if this is 8 radical 3, I know that the whole thing here, the whole side, is 16 radical 3. From here, I should know how to compute the perimeter along with the area, and this is what you get. And this concludes the video for section 5.8.